Hi, this is Dr. Ben Morrill. Welcome to episode 87 of Reptile Genetics Weekly. Glad to have you here. And this month and next month are going to be very exciting months. We have a whole bunch of research stuff coming through, like we talked about a couple episodes ago. We should have several new tests by the end of the month, and that's progressing along really nicely. As far as updates for results, we've got fast tests going out pretty much every day, sex determination going out as has been for several weeks now, usually a couple times a week. The next panel results will likely be late next week, so probably Thursday, Friday next week. So about a week and a half from when you're seeing this episode. We should have the next panel results out, and that's also when we'll get some more specific information about what new tests are good to go. So we'll probably be kind of towards the end of the month when we'll drop several all at one time, kind of like what we did the last time with the 10 that we released. So fun times ahead. I'm very excited. Lots of long nights, but they're exciting long nights. So cool things. And then this episode, as you saw in the thumbnail, we've got a really cool topic to talk about as well. Very, very excited about that and to have Justin here. But yeah, that's what I've got for updates for today. Kayla, how are you doing?
Hey, Ben, I'm doing well. Getting excited. I'm kind of bummed and excited. I'm putting my snakes down for brumation, and so they're chilly. I miss them. But just last week, Ben helped me ultrasound 5 of my girls to make sure they didn't have any eggs before they went down in the cooler. And by cooler, I mean they're like, some of them are going in a wine cooler, others are just going in my closet because it gets kind of cold in there. So it's interesting times in the colubrid world, but I'm hoping for a much better year than I had last year, pairing like 2 or 3 of them, depending how it goes. But yeah, cool. I'm excited, and I'm really excited for basically for the new, like the next couple of runs coming in, and for mostly the research runs, because I want to know which tests we're going to be able to release next soon.
Yes.
So it's good. But for business stuff, for those of you who missed out on the November sale, you can still get shed testing at a lower price by considering bulk orders. You can get them in advance, whether you are doing ball python mutations or sex determination in ball pythons or colubrids, and hopefully even more stuff happening here soon. But if you order it in bulk, shoot an email to us at raregeninc@gmail.com. You can get a quote from Sean that way. And especially for bulk colubrid sex determination, you can get it as low as like $15 per test. So get it before you even start pairing things up. We will honor it all through the year, so you can pick from it when you're ready. Let's see. Last week, we also wanted your input on panel test speed, whether we should up the price a bit and make it even faster, or just keep the prices as low as possible and keep going the way we have been. And overwhelmingly, people we had 102 people go in and vote, and overwhelmingly people seem to prefer that we continue to keep the prices as low as possible, and they're okay with waiting for the 3 to 5 week turnaround. So thank you guys for the input. We really appreciate that. And you can still vote on it. So if more people come in and that happens to change, at least we'll know what y'all are thinking. So we really appreciate it.
That put together with the last one means y'all want a really big panel with everything in it, and you don't mind waiting. So yep, that's doable. We'll work towards that.
Definitely. I know a lot of people said that it was more like they can get a few more meals into their babies, even if they have to wait for a ton of morph tests to come through. They can get their panel and get some more meals in their little guys. So, which is totally fair. So, works for us. And thank you guys for the feedback. Also, the Herp and Harbins featured our very own Sean on their industry insight segment on their YouTube. So definitely go check it out. You can see Sean's like scary dungeon basement and get some cool industry insights from somebody who, well, we get an interesting insight on like trends, I guess, in the ball python world, because we're getting so many different orders. So personally, I know I personally want to watch that because I don't always get to, talk shop with Sean. So definitely worth checking out. They just have a few different videos right now, but all of them are bangers just to start out with. Like, I know all of these people. You've got Antoine, you've got Leviathan Snakes, you've got Small Town Exotics. So definitely check them out. They've got shorts on there too, if that's more your vibe. And we love the Herp and Harbins. So we're really glad that they brought us on.
Yes.
Yeah. So let's bring on our special guest today, Justin of Nova.
How's it going, guys?
Good. How about you?
Good. Excited to be here. Thanks for including me again.
Of course. Always glad to have you on. So you had another interesting clutch recently. So you want to
Yes, we
tell
have
us about
enough of them that it just keeps popping up. Interesting stuff. So thanks for
Yeah.
helping me figure it out and suggesting that we talk about it here for everybody.
Yes.
Yeah.
This is a specific potential occurrence that I've been keeping my eye out for and hear potential things about androgenesis. But this is the cleanest example that I can think of, especially with the pairing and how good of records you have and everything. This is about as perfect as it can get.
Yeah.
Good. Well, it'll be a good case study for other people to figure out their own stuff with then.
Yeah. So tell us about this pairing.
So yeah, it was just a pairing to make some double het puzzle desert ghosts, which, puzzle desert ghosts are amazing. So we're all about, just kind of increasing our stock of those. And so we did a red stripe puzzle male to an Inchy Fire. That's the boy right there. To an Inchy Fire Cypress Spot Nose Desert Ghost. It was her second clutch for us. She's gorgeous, amazing.
She's so pretty.
Yes.
Like, I gasped when you sent me this picture just a couple minutes ago. I was like, oh, dude.
Well, the Cypress Spot Nose is a lilac, so it acts like super with those. And she just glows. So yeah, the red stripe puzzle was a world's first as well. Beautiful boy. We've used him quite a bit over the last couple of years, so he's well proven and very simple, straightforward. And yeah, we got some interesting offspring.
Yeah.
So let's dive into those. Yeah, we cut the clutch for our Patreon, and we showed it, and everything was great, exactly as expected. We had some that were spot nose and some that were cypress, right down the middle kind of thing. Everything made sense. The only thing that was a little strange is we didn't see a single red stripe from the dad in any of the offspring until we got to the last egg. And this is the last egg in the clutch. It's always the last egg that's either the best.
Of course.
It's like, that's weird. It's really weird. And it doesn't matter what side of the clutch we start on cutting, it's always the other side. But yeah, this was a puzzle. When we cut it open, we saw a visual puzzle. And I thought, Partho. Whenever I see like an unexpected homozygous animal, I always think Partho.
Yeah.
And I think it was Summer saying next to me, she goes, wasn't the mom a desert ghost? I'm like, oh yeah, it was the dad that was a puzzle. Like,
wait a minute.
How does that work? And then I thought, it's a gene deletion, like we've talked about a little bit in the past, Ben, where you get an unexpected homozygous because, a gene was damaged and it's only expressing one side, right? You know, of course. And this is the amazing animal that came out, which looks like a really extreme red stripe puzzle. Yeah, that's the story in a nutshell of how this animal came to be and our confusion with it and not knowing what's up and not seeing any red stripe in the other offspring. Immediately, of course, we shed test the entire clutch.
Right.
And all the rest of the offspring were het DG and came back as het puzzle. And then this one came back as puzzle and not het DG. So even though it came from the mom, it didn't carry her het desert ghost, didn't get the het from her.
Yeah, she's visual DG. It should have been a het.
Should have been a het. So that's where my knowledge stops and Ben starts.
Yeah. No pressure, Ben.
Yeah. This was definitely an interesting one. And it's really nice that you knew the sire had puzzle and no DG, and then the dam had DG and no puzzle. That really helped to have that pairing, to kind of take out any possibilities. And then with of course, the genetic testing, then we know for sure that all the other offspring did get the DG from the mom. And you said this is her second clutch. You knew that, she was what you thought she was.
Yeah.
Sure.
So the other thing that was very interesting for me to think about is where this is coming from a sire this time. We talked about parthenogenesis many times, but with androgenesis, the sex chromosomes are different. So in a male in ball pythons has an X and a Y, and in ball pythons, the female has a XX. So when the female does partho, it only has X's to give. So all the offspring from parthenogenesis from a female, that's just going to be females. But from a male, you'd have potentially two different outcomes for the sex chromosomes. And so one of the things I was really interested to know from Justin is, okay, this crazy looking baby, is it a boy or a girl? And it's a girl. And then also, it's interesting to note the how well the offspring thrive, because we know with partho, a lot of the time we have issues. One of the partial partho clutches I had, I also saw like the umbilical cord and the attachment to the sac and everything was messed up in that one. I don't know how common that is, but it was noticeable. Like, first of all, it was a super Mojave, and that shouldn't have been possible from the pairing. But then looking at the umbilical cord and the sac and everything, it looked really messed up. It didn't look. I've hatched out lots, and I've hadn't seen one like that. So that was another question I had for Justin. And so, Justin, how did that clutch do, like out of the egg and over the next, little bit?
Yeah, all the offspring did great except for the one baby, the one visual puzzle. He or she skipped her first shed, and was kind of a runt baby, didn't absorb his yolk very good, skipped his first shed, was a little bit smaller than the rest of the offspring. And you can see in that picture, he's still shiny. She's still shiny. We took a picture of her right out of the, with the other ones, but that one skipped a shed. And so then we tried to feed it, and it wouldn't eat, and all the rest of them took off eating, and that one wouldn't eat, as we had to assist feed the first meal. And now, actually, with that last picture, it had shed out, and it's eating great on its own, and it seems great. But it definitely didn't, thrive on the same level as the rest of the offspring in the clutch.
Yeah, so that's another question I ask people a lot of the time, if they think that there's potentially a partho, and in this case, andro clutches. Did you lose eggs along the way? Did you have malformations, dead in the egg, issues? Did you have babies that just didn't seem to thrive, or a whole clutch if you think the whole clutch is partho? So that's another thing to think about. If you see genetics you didn't expect, and you see something weird, oh yeah, I did have a couple eggs go bad in this clutch. Those are all signs, that there's some partho or andro going on. So the interesting thing, many of you may think, okay, partho from a female is going to make all females. Andro from a male, does that make all males? Or, what's going on with that? So we wanted to kind of lay out the sex chromosomes and talk about it. The case why when Justin told me it was a female, I was like, yeah, that does make sense, because off the top of your head, it might not make sense. Yeah. So in ball pythons, and it is different from other snakes, colubrids and the venomous snakes, lapids and vipers, they have sex chromosomes like birds. They have ZW, but in ball pythons and boas, they do have XX and XY like we do, like humans do. So in this case, where you have a male, so here Kayla's got them, the hearts there, them, they in love. So that's a little nicer than just having the X there, you got the heart. So we breed these two together, but when androgenesis occurs, nothing comes from the mom. So we've got her pushed off to the side. So you just have that X and Y from the male. And we talked about in the past, we've done a couple of episodes on parthenogenesis. And what happens is whatever the female has, like if she's het for clown, her offspring are either going to be clowns or they're going to be negative for clown. You're not going to get a het clown from her. And that's because that chromosome that the clown gene is on, you're either going to get an egg that has the clown mutation, and then it's going to double, which will make a clown, or you'll get a clown, an egg that doesn't have the clown mutation, and then it'll double, and then you get a normal for the clown mutation.
If you want a refresher on that, I'm going to either link it up here or I'll link it in the description or both. But it's our half-cloned episode. So half-cloned pythons. If you search that up in our videos, that'll be the one. So you can get a better refresher on what we're talking about.
Yeah. So in this case, as far as sex chromosomes go, the male can give either an X or a Y. And so whichever one is in that sperm, it's going to get doubled. And so all you could get from androgenesis would be an XX or a YY. And so an XX would give us a female and should be normal. That should be fine, you know, as normal as something that's a half clone, which is essentially highly inbred. But then the other possibility would be a YY. And I did some searching to try to figure out if there have been any cases where people have talked about androgenesis in reptiles where they do have a YY offspring that lives. This is so rare, first of all, and then it'd be even more rare for them to then be able to breed that female or that, to breed that male.
Yeah, it'd be a male, right? But it'd be a different male.
In this case.
Unusual, a double male, super male.
Yeah, it would be a super
Yeah.
So where they would have actually bred that one and produced offspring, or they would have at least been able to do the testing to know that they had a YY male.
If you did have a YY male and bred it to a female, all the offspring would be males, right?
Exactly.
If you could get it to breed. Yeah.
That's our next slide.
Oh, well, there you go.
Yeah.
Yep, exactly. So in that case, so first of all, if that YY male can live, which we don't know for sure if it could, but so if you have androgenesis occur, you get a male and you do the testing, find out it is YY. If he was able to breed, then yes, because he'd be breeding to a female, which in ball pythons is XX. You're breeding XX to YY. Every single baby is going to be XY. And so that male would only be able to produce male offspring regardless of which female you put them with. So if any of you yourselves or know someone that's has a male that produces all males, it could be that he came from androgenesis.
That would be cool.
Right?
Yeah, it's possible, you know.
Yeah.
That would be crazy.
Yeah.
But it would be a bummer unless it's like brand new genetics where you want to make a bunch of males. And then in researching online, you know, first of all, like we said, parthenogenesis itself is rare. But like now that we're doing as much testing and then Justin, you know, producing as many clutches as he does, we do see it. Like it's rare. You don't see it, you know, in every clutch or in every, you know, maybe every month or every breeding season, depending on how many you're producing. But now that we're doing a lot of genetic testing, it seems to be almost every week where somebody's like, well, this doesn't make sense. And we found out, okay, yes, it's a female and yep, it's got double what the mom had. And yeah, so Partho is rare, but andro is even
rarer.
Yeah, rarer of the rares.
So can you from your position there with RGI, can you write a scientific paper where you can actually begin to quantify that parthogenesis is not rare in ball pythons, at least? Because the first time we have data, because I think the understanding was that this is probably super rare, and in reality it isn't that rare statistically, right?
Yeah.
Yeah, I mean, it's, you know, it's something that doesn't surprise us when we see it. It happens enough, we're not surprised.
Right.
But yeah, that's a good point. You know, I don't think there have been some parthenogenesis papers. Dr. Warren Booth, that's a boa breeder and has done some ball python work. He's done some papers on boas and ball pythons specifically.
On frequency and how they're maybe not as unusual as we thought, right?
Exactly. Yeah. This would be new data where we have this, you know, data set from all of you that are doing testing. That's a great point, Justin. We'll have we'll have to track back and pull some numbers together, because I would imagine there's several people, and for other species as well, would be kind of interested to know what we're seeing in ball pythons as far as frequency.
Yeah, we could certainly say
interesting.
out of X number of clutches, we have 3% or 4% or 5% are have Partho. And I'm curious to hear your thoughts too on, we're seeing I wouldn't say increased occurrence, but now we're aware of the occurrence of a single Partho baby with the rest of the clutch sired by a male.
Yeah.
And how Parthogenesis is not just like one or nothing, all or nothing kind of situation. It can grab a single egg out of a clutch.
Yeah. So would you say you see it more commonly that only one or some, you see partial Partho more often than entire clutches being Partho?
I would say yes. Yeah.
Yeah.
Which is a little scary for without shed testing, because
Yep.
you might think that it carries genes from the male and it just doesn't, right? And in the past, we wouldn't know better.
Yeah. The episode that Kayla was talking about, it's a case study where someone purchased a leopard het desert ghost female and sent it in for a panel test, and it tested negative for DG. He's like, well, the sire was a DG, and we're like, okay, but when we did the panel test, it said that the leopard, it was homozygous for leopard, and the sire didn't have leopard, but the mom did. And so that's exactly what you just said, Justin, is, the breeder assumed from the breeding that every baby had to be het for DG. But actually, in that case, we let him know any of your offspring in this clutch, because it was a partial Partho clutch, any of the offspring in this clutch that are female, you'll want to get tested to find out if,
unfortunately, super leopard isn't obvious too, because if super leopard had a visual difference, he could have been like, this doesn't make sense. But it can be a super leopard and you'd never know by looking at it.
Yep.
So interesting.
Yeah. And in that case, we even sequenced the whole genome of that individual, and it was very clear that it was very extremely high level of homozygosity. That's what we see in Partho animals. So we went above and beyond to make sure, because it was an animal that got purchased by someone else, and there's some a little bit of discomfort in between, but it was very clear that it was Partho and was not. And we just had that happen again. I think it was last week. Someone else had one that should have gotten, I think it was het clown that time. It didn't make sense that it didn't. It shouldn't be possible. And then, through testing, like, oh yeah, it's Partho, and you didn't get what came from the dad because the dad didn't give anything. So, but yeah, I would have said the same thing. It's more likely to be a partial clutch than an entire clutch. And, that does definitely make it more complicated, because it can sneak past you.
For sure.
So in looking at androgenesis online in other animals where they talked about this, the mechanism by which that happens, it seems to be one of two things. One is that the female ovulates an egg that does not have a nucleus, so it doesn't have that DNA from the female. So everything's there for that egg, but there's no DNA there. And then the sperm comes and fertilizes that otherwise normal egg. And since there's no other DNA there, then the only DNA it can use is the sires. And so if it splits, it doubles that DNA so that there's a full complement to make a baby ball python. Then you just made a half clone of the dad. So the other one, they call it, I'm going to read this, make sure it's genome elimination. So there would be some way in which it's a normal egg with the DNA, it gets fertilized, but somehow that female part of the DNA gets eliminated and the males gets doubled. So there is some information there for other species. I'll have to look some more, but like I said, I've heard people say, hey, maybe this is andro, hey, maybe this, but each time we've kind of tracked it down, it's not we haven't been completely sure, but in this case, it's such a clean example with the pairing that I can't think. Justin and I, before we started recording, we're kind of talking about, maybe it could be this or that. And I mean, any of you feel free to jump in the comments if you can think of another explanation, but this is pretty clean.
And it visually looks like what I would expect a super red stripe to look like in the puzzle. That's not been made yet, outside of this animal potentially, but it does look like dad, doubled in a way, like a super red stripe potentially. So
Yeah.
So the next thing is, does this count as a world's first? I was saying no, it doesn't count, because same as a Partho baby, it seems like a cheat code to get ahead when you haven't done the work. So
Yeah, well, I personally say yeah, but also it might look totally different from a quote unquote real one that was produced and doesn't have this presumably insane level of homozygosity.
right.
So yes and no.
For sure.
Your opinions may vary.
Yes.
It will be cool to see when one is produced through normal sexual reproduction, if it's a carbon copy of this or if it is a little
Yeah.
bit.
Well, I hope, despite his very interesting origin, I hope little dude thrives despite that.
Girl.
So are you gonna?
Yeah.
So what are your plans for him going forward?
Honestly, on animals like this, I'll usually grow them up for a little bit, enjoy them, but then when they're either Partho or probably even this animal, we'll probably honestly give it as a pet to somebody.
Yeah, makes sense.
We're breeding. We want animals that are going to produce someday. So we'll either give it to a local person or we'll give it away on our Patreon as a pet. And sometimes you get some very visual, beautiful animals as pets. So yeah.
Cool.
Awesome.
Well, that's definitely a gem. It's a first as far as andro goes. The first andro super red stripe puzzle, that's for sure.
There you go.
Yeah.
Yeah.
Too cool. Yeah, awesome. Well, thank you for joining us today, Justin. It's always a pleasure to have you on. And of course, thank you guys for watching. Let us know what you think. Is it a world first or not? Have you gotten any cases where you think you've had an androgenesis ball python or any species? I think once we branch into mutation testing for other species too, we're probably going to start finding interesting cases like this too. But it'll be on ZW chromosomes, and then we'll have to tangle with how that affects the outcome. So really exciting. And yeah, so make sure you like and subscribe. Comment, and I guess we'll see you next time, guys.
All right. See you guys.
See y'all. Outro in 3, 2, 1.